All right, let's get started today with our new unit on systems of equations. So we are going to be looking at solving systems of equations using substitution just by solving for a variable and using the original equation. Now, as we get started with this, the one thing to realize is that we are still talking about linear equations. The only difference is we're talking about two or more. Specifically, we're going to be dealing with 2 in Algebra 1. You'll be looking at more than that when you hit Algebra 2. And they're going to look at 3 different methods of solving with systems. And we're going to start with substitution. So let's go ahead and get our mind back in solving for a variable. So take a minute and go ahead and take this do now and solve for y. Okay, let's see how you did. So remember, we know that solving for y means we have a times 2, which is a divide 2, a minus 4x, which is a positive 4x. So the first thing that I do when I'm solving for a variable is always move the other variable. So the opposite of a negative 4x we know is a positive 4x. So I'm going to add 4x. That gives me 2y equals 4x plus 8. Remember, variables come before the numbers. And then I'm going to divide by 2. 3 times. Crosses out. 4 divided by 2. Remember, 4 divided by 2 is going to simplify to 1/2. Our Desmos calculator is our good friend, so make sure you do have that open and you're using it. And so I have 2x, which is really 2 over 1. Whoops, let's flip that. That's 2 over 1, not 1/2. And then plus 4. So the key to solving systems by substitution is what we just did here, solving for x or solving for y. And it doesn't make any difference which one we solve for. We just have to solve for one of them. Okay, we have some key vocabulary in this unit, and we already know what substitution is. So that isn't a new thing. So for example, if I give you 2a plus 3b and I give you a equals -1 and b equals 2, we know that substitution means we're going to use parentheses. We're going to drop in those numbers where the variables are, and then we're going to evaluate. So 2 times -1 is -2, 3 times 2 is 6. -2 plus 6 gives me 4. The substitution method means we're going to be using substitution to take an equation or a portion of an equation and put it into the other equation. So for example, if I look down here at this set of equations, I can see that I have one of them solved for y. So what I'm going to do is I'm going to take the other part of the equation and I'm going to substitute it in where y is. So it ends up looking something like this, where I have a simple equation to solve with one variable. So I'm going to solve it like normal. Okay, so the only thing that is different is we're going to take an equation and substitute in instead of just a number this time or an expression. The other thing that we already know is standard form. Standard form is ax plus by equals c. Okay. Excuse me. So when we are looking at systems, there are 3 different types of solutions. Now, I know you remember back from last semester when we were talking about parallel lines, and we know parallel lines, they never intersect. So these lines are parallel. Okay? They have the same slopes. They never intersect. Now, I want you to look at what the solution is. It says there's no solution. If I look at the most common type of problem, which is in the center, that is a one solution, which means I'm going to find the answer. I'm going to find one answer, okay? And you'll notice that it says the answer is where the lines intersect. So the reason there's no solution on parallels is because they never intersect. So there's no touching. There is no point where they intersect, okay? So the solution, the answer to a system is going to be an ordered pair. It's an x and a y. Then we also have infinitely many solutions. Okay, infinitely many solutions. So this is pretty similar to regular equations. We always have an infinitely many option. We always have a no solution where it doesn't work. And we have our infinitely many. And if you remember, the infinitely many meant we had both lines on top of each other. And if you think about where these are intersecting, this is intersecting in more than one point. So that means every number works. And you may remember us talking about how the x's go away. It's like on an equation, if I have 8x minus 4 equals 8x plus 2, if I subtracted these 8x's, all of a sudden I have a 0x. That triggered the no solution and the infinitely many. So what I'm left with is negative 4 equals 2. Well, this is where you have to decide true or false. Okay, and that determines, is this possible? Well, if it's not possible, then it's a no solution. If it's possible, like 2 equals 2, then I know it's an infinite or infinitely many solutions. Okay? All right, so again, we're going to be looking for an ordered pair, which means we have to find an x and a y. So let's get into the work of this. Okay, here's our steps. The first thing we're going to do is solve for an 1x or a 1y. Okay, we're going to solve for a 1x or a 1y. Then we're going to substitute into the other equation. We're going to solve, and then we're going to substitute back into our original equation. So if I take a look at these two equations, which variable should I solve for? You always want to look for that 1x or 1y, and you can see that right here, there's a 1x or a 1y. So that's pretty easy. I can solve for y right there. I know y is going to be equal to a negative 2x plus 3. Remember, that sign has to change. So that means that this equation is now gone, and I'm using that one. The next one, I don't see a 1y, but I do see a 1x. So I can certainly solve for x. So negative 5y minus 6 is equal to the 1x. And this one is now gone. Okay? So it doesn't matter. We get to choose. And sometimes we're going to have to be looking for multiples to make it a little bit easier for ourselves as we start to solve. And we'll look at that as we go further today. Okay, so let's take a look at what we have here. So the first thing I'm supposed to do is solve for 1x or 1y. Well, in this case, they're both y equals, which is great. I'm already done with that step. So the second step was substitution. So what I'm going to do is I'm going to take the top equation and I'm going to substitute for y, which means it's going to go right here. So I have negative 2x plus 10 equals. And the original equation that we were substituting into is 3x minus 5. So now if I look at what I just have a regular equation. I'm going to move the x's to the left, I'm going to move my numbers to the right, and I'm going to solve it. So I'm going to subtract my 3x. That is gone. A negative 5x plus 10 equals negative 5. Again, I'm going to subtract my 10. So negative 5x equals negative 15. If I divide by negative 5, x is going to equal 3. Okay, now that's important because remember, my answer is an ordered pair. Okay, my answer is an ordered pair. So since x is 3, I know that I should have x and y. So my 3 is going to go on the x side. All right, now I still have to find my y. Okay, and this is what's kind of cool about this. So I go back to, and I'm going to label these equation 1 and equation 2. Since both of these are y equals, it doesn't really matter which, in this case, which one I substitute into, but I always choose to substitute into the one that I solve for, or the one I substitute into the other one, which would be equation 1. Okay, so if I take equation 1, y equals negative 2x plus 10, I'm going to take this 3 and I'm going to put it in for x because I know it is x. So negative 2 times 3 plus 10, that is negative 6. Negative 6 plus 10 is going to give me 4. So I have y equals 4. So my second solution, or my second answer in my solution is 3, 4. Okay, now to check the solutions, you have to check both sets. So we know when we substitute in to check in a regular equation, we just substitute in our x and substitute in our y. So the 4 would go for the y, and I would have a 3 in for the x. This is equation 1. So I have 4 equals negative 6 plus 10. I see 4 equals 4. I know that is true. So I know I solved the first one right. But I have to check the other equation because there are 2 of them. So again, I'm substituting. 3 times 3 is 9. 9 minus 5 is 4. I have 4 equals 4. I know I'm correct. If they both do not turn out as true, then I know I did something wrong. Okay, let's keep going here and take a look at the next one. Okay, so again, first step is solving for y. And on this one, it's already solved for y, so that's done. So I know I have equation 1 and equation 2. So which one is already solved for y or x? Equation 1. So that means this is going to substitute into the second equation. So where is it going to go? Is it going to go in next to the 5 or is it going to go in for the y? Well, it's the y. So it needs to go into that second part. So 5x plus, and remember, there is a 1 there. It doesn't technically impact us this time, but we do need to remember that there actually is a number there. And if I had to distribute, I would. So I'm going to go ahead and just distribute that 1 through, even though it doesn't change anything. And I'm going to finish solving. So 5x and 3x, that is 8x plus 2 equals 2. I subtract my 2. I get 8x equals 0. Dividing by 8, I know x has to equal 0. So I have the first part of my answer. I know my x is 0. Okay, so again, since I have equation 1 that is already in simplified form, that is the easiest one for me to use to substitute my 0 in. So in for the x is going to go my x equals 0. So y equals 3 times 0 plus 2. That goes away, so y is going to equal 2. So my solution is 0, 2. Okay, let's check it. Y equals 3x plus 2. So I have a 2, a 3 times 0 plus 2. 2 is going to equal 2. That is true. Okay, let's try the other one. 5 times 0 plus y, which is 2, equals 2. We know that's gone, so 2 equals 2, and again, I am with a true, and I know that I'm right. Okay, let's take a look at this one. So this one, we do not have something that is solved for x or solved for y. Okay, but we do have an equation that has singles. We have a 1x and a 1y. We have a negative 1x and a positive 1y. So let's go ahead and solve this one for x, just because we can. Okay, we can. We can solve for x or we can solve for y. It doesn't matter. But let's solve this one for x. So this has a 2 and a 3. That's not what I'm looking for. I see that this second equation has a negative x, a positive y, and a negative 1. So let's solve for x. So I know that's a negative 1. So I'm going to move the y to the other side. So I have negative 1x equals negative 1y minus 1. Remember, I need a positive x. Let's divide by negative 1. And let's get x equals, that's a positive y and a positive 1. So that's nice because I don't have any negatives. And this equation is now gone, and this is now equation number 2. Okay, so let's go ahead and substitute in. This time, we're going to be substituting into the top equation. So let me go ahead and write that top equation out. Now, since this is x, it is not going to go next to the 3. It's going to go in by the 2 because it's x. So 2 parentheses minus 3y equals negative 1. I have a y plus 1. And let's solve it. So let's distribute. 2y, 2 times 1 is 2. Drop down my negative 3y and my negative 1. And then I'm going to combine like terms. 2y minus 3y, that's a negative 1y, plus 2 equals negative 1. Remember, I need to move everything away from the y, so I'm going to subtract my 2. And I have negative 1y equals negative 3. And I can't leave that negative 1 there, so I end up having to divide by negative 1, and I come up with y equals 3. Okay, now, is that going to go in my first spot, or is that going to go in my second spot? Because it's a y this time. If you said the second spot, you're right. That's going to go in the second spot. That's my 3. Okay, so to find my x value, I could use equation 1. It's just going to be a lot more work. Equation 2 is already x equals. That's what I'm looking for. I'm looking for x. So it's much easier to use the new equation that I solved for to be able to find that variable, because the hard part, the math, is already mostly done. So my 3 is going to go here because it's my y. And 3 plus 1 is 4. So my ordered pair is 4, 3. Okay, this time when we check it, we're going to have multiple substitutions to do. So we're going to use the first equation, and it's standard form, and that's okay. I'm going to put in my 4 and put in my 3. So 2 times 4 is 8. Negative 3 times 3 is negative 9. That gives me a negative 1. Negative 1 equals negative 1. That is true. Checking the other one, I can use this one. I have 4 equals 3 plus 1. Yeah, that's true. 4 equals 4. And that one is true. So I know that I am good to go. Whoops, I went too far here. I got a new computer today, and it's having some adjustment period here. All right, let's look at this one. All right, what do you see? Do you see a 1x or a 1y? I see 2 of them. I see a 1x or a 1y in equation 1, and I see a negative 1y in equation 2. So in this case, we get to choose. I think I would probably choose the first one because it's a positive y. It'll save me some work. So let's solve this one for y. So y would equal, move my negative 7 becomes a positive 7x minus 15, and this equation is now gone. All right, let's substitute in 3x, and I'm going to put a negative 1 there so I don't forget that there's a negative 1. And I have to substitute in for y. So is that going to go for my 3, or is that going to go next to my negative 1? If you said it's going to go in for the negative 1, you're right. So 3x minus 1. Drop in my 7x minus 15. Okay, go ahead and hit pause and see if you can solve for the x value. All right, let's see how you did. 3x, distribute, negative 7x, distribute, positive 15 equals 3. Combining like terms, 3 plus negative 7 is a negative 4. I'm going to subtract my 15. I have negative 4x equals a negative 12, and I'm dividing by a negative 4, so x equals 3. Hopefully a whole bunch of you got x equals 3. Okay, so again, that's going to go in the first spot because that's my x. All right, let's finish this up. So am I going to use equation 1 or equation 2? Which one's going to be easier to find y? You're right, equation 1, because it's already y equals. Okay, remember x equals 3. Go ahead and hit pause, substitute, and see if you can solve for y. All right, let's see how you did. So the 3 goes in for the x. 7 times 3 is 21. 21 minus 15 is going to give me 6. Y is going to equal 6. Okay, take a minute, hit pause, and check it. See if you did it right. Okay, let's do our first check. So I'm picking equation 2. That's my longest equation. I'm going to put in my x, and I'm going to put in my y, and I'm going to evaluate. 3 times 3 is 9. Negative 1 times 6 is negative 6. And 3 equals 3, so I am correct there. The second equation, y equals 7x minus 15. I put in a 6. I put in a 7 times 3. I already know that that is 21 minus 15, so 6 equals 6. And there's always one of the equations that's easier to solve than the other because you use that in the problem as part of the substitution to find the equation. Okay, one more, I think we have. No, maybe we're done. I think we're done for today. Okay, so you've got some problems to work on today. And this is going to be a little challenging, so don't get frustrated. Go back and look at the process, look at your notes, reach out to us if you're struggling. We'll get you going. It'll take a couple days to kind of get this straightened out in your head. But remember, solve for 1x or 1y, substitute in, solve for the other one, and the answers are ordered pairs. Have a good day.